welcome to the stream. Apologize for the tech issues. We're going to be doing a Kīlauea update here with geologist Philip Ong, sorry. I'm Dane DuPont. We're going to go through Kīlauea and Maunaloa again today. Just a little bit different. Had some tech issues. Hopefully got them sorted out. Thank you guys for bearing with us during this whole process. So we're going to start off with Kīlauea, and then we're going to take some questions and then transition into Maunaloa. So with that, Philip.
Yeah, thanks, Dane. Yeah, thank you guys for joining us today. Yeah, it's Thursday, June 24th, 2021. And yeah, Kīlauea and Maunaloa are both still seismically active, and the story this last week has just been a slightly shifting patterns. Small shifts. Maunaloa not as much. It's actually still quaking on its southeast flank. Kīlauea, it seems like it's more at the summit. So we'll talk about that, the pattern of the earthquakes. We'll look at some of the monitoring signals and some of the nuance in there too. Yeah, and Dana is going to be driving the presentation today as I narrate, and Dana will be monitoring the streams as well. So if, like earlier in our first attempt, we're having issues, please let us know over the chat, and Dane will do what he can there. Otherwise, he'll be collecting questions for us to answer between Kīlauea and Maunaloa, and then again at the end of Maunaloa, and answering questions on chat too. So mahalo, you guys, for joining us today. There is a surprising amount of stuff to talk about with these volcanoes that are not erupting lava on our surface. So we'll get right into it here. And Dane, maybe you can start us off here with a view of the KW camera of the summit there, right? That's just what the summit of Kīlauea looks like right now. And over the past 24 hours, you guys can see there's really not a whole lot of glow at night. Pretty dark there. You know, it's been full moon, right? Obviously, so you do see some illumination of that sulfur bank there on that north wall. On the left of that image there at the bottom, that's animating. And yeah, it's been pretty quiet. So we'll rotate through the views here, and we'll move next to the S1 camera, which is on the south rim of the volcano there. And same thing, we don't have any animation with this one, but it's quiet, hasn't really changed. But that's the views that we have of the volcano there from the south. And then we'll iterate the next path around there to the view from the east side from the B1 camera. This is a capture from earlier today, right there. Yeah, there it is. Yeah. B1 camera, and yeah, pretty quiet there. But thanks to Marin Purvis, one of our Hawaii Tracker administrators, she caught the next image here in our sequence, which is the B1 camera last night. And there's a little spot of glow right there in the middle, just right at the center of that image, and I don't know if you can zoom in on it at all, Dane, or if that's not asking too much today, but it's just a little spot right in there, and it's not a whole lot. It only lasts one frame in this playing in this sequence that we were able to catch last night. So something very short-lived, very localized, very small. If you line it up with a previous image, I'm not sure how well that will line up, but if you go back and forth from the day and the night, you can kind of see that glowing spot is a little bit to the right of that tip of that big island in there. So it's not really near the west vent. It is on that west side of the crusted lava lake, but it's probably one of those overhangs of that western lava lake surface that maybe there was some little settling or something, and you get a better view from that angle into that crack, or maybe the settling allowed some extra heat and gas to come out, so it caught in one camera from one angle. It's hard to say exactly what's happening, but you know, some small changes are definitely worth talking about and interesting. And you know, people may if you still watch the webcams, you may still catch one of these rarer events of frames of glow or something like that. So if you guys are seeing that, please capture it and pass it along to us, and we're happy to include it here in our future broadcast as well. So mahalo, Marin, for that. So looking into this a little bit more, we'll iterate to the next camera, which is the F1 camera, the thermal camera. From the USGS there, and we can look at and right now, you know, there's the scale on the right there only goes to 180, 200 degrees Celsius, and you see a couple of hot spots down there, the west vents at the very bottom, and a couple of slightly pinker areas in there. Yeah, if you scroll down into that 24-hour animation, you may be able to see that there's, during that course of time from last night, there was no flash of heat or anything like that happened. That image was from last night, somewhere in a 10 p.m., 10:30 p.m. range, somewhere in there. So I included this animation. There's no change thermally. Really, it was just some particular angle. And from this F1 camera direction, which is the opposite point of view, it's probably that glowing spot to the left and slightly up from the vent. So I don't know if you can possibly zoom into that, Dane, so you can get a maybe bigger on a screen there, close to the west vent on an animated image.
We're
Down there, and yeah, so there you go. So it's not super bright there, but it's right below your pointer there, and left of the west vent up a little bit, and so it's something in there. You can see there's really not a whole lot of change, but worth mentioning it, and we won't belabor the point there. But I am curious if anyone else will catch any of those in the future, so keep your eyes open for that. All right, so looking at the USGS weekly update there. There is not a whole lot of change in the report. We're not seeing any mention of anything like that glow, so it's really small and localized, and apparently from that point of view, not even worth mentioning on a USGS weekly update there. The newest, most recent information is the SO2 emission rate, 50 tons per day still from June 16th, last week. So not a whole lot of change there. And otherwise, no other change, nothing written observations of the lava lake. It just says completely covered over and no evidence of recent surface activity, right? And no changes in the East Rift Zone observations, which still indicate filling as well. So we'll move on from that. I just want to make sure we always touch base there with the authorities of what might be going on. And if we see that they mention something like that activity on the surface of the lava lake, we could reference it there, but not the case yesterday. So of course, that update goes back to Tuesday, so maybe this wasn't something that happened the previous week, and maybe it will be worth mentioning next week, maybe not. All right, so but the SO2 measurements are the next slide here, and that most recent point on the right, that's that 50 tons per day, and we're still in that range over the past month. It hasn't really deviated a whole lot. There is that one higher measurement just at the tail end there, somewhere around the 28th. But really, since the 29th, it's been in that range of really about 50 to 70 tons per day, with not a whole lot of variation, a little bit up and down, but really not a whole lot. So moving on to the depth of the lava lake. For the past month there, we can see that that big drop that's over in the middle, to the left of the middle of the graph, that's that original settling event. And so since that drop, you still see those cycles every day, but we're having maybe a very, very slow decrease to the right there. So we'll go to the next slide there, and we'll zoom in to the last week, that is. And you can see those animations a little more closely, or those cycles a little more closely, daily cycles. But the baseline may be very slightly dropping on the left end of the graph there, is at somewhere at maybe 22.83, we'll call it. And at the right end, it might be 0.78. So something very, very small, possibly with an error within the resolution of the instrument. It's not changing a huge amount is the bottom line there. The most important thing. It might be still slowly settling and contracting, as is expected that it would do for a long time to come. So that's kind of covering our bases with the gas and the level. And so now we can look at the deformation data on that volcano and start off with that upper plot of the 2-day tilt. You can see that we're in the middle of a deflation-inflation event that started off at positive 2 microradians and it's down to negative 2. So it's still ongoing 4 or 5 microradians. It's about the size of these larger events we've been having, about one a week since the end of the eruption, maybe since the week after the end of the eruption, something like that. So if you scroll down here to the last week graph, you can see the one that we're in currently at the right side, that kind of trough, and then the one on the left that just happened last week. So we're actually sneaking in a little bit faster here. 2 big ones this week, and possibly you might see that one in between, a little dip in between at the top there. Possibly that's a small one as well, right? And there's a little bit of extra ink on there where there's a couple of earthquakes right there in that small little dip at the top, right past the 22nd of June. And also all the way back on the 17th, you see that other little scratch on the record of a earthquake jolt as well. And so that's why I've been talking about earthquakes. Earthquakes has been most of the signal. We still have these deflation-inflation. Still thought to be background by a lot of researchers. And we have heard that USGS say that fairly recently. So looking past the background at that plot of the whole month there, you can see that if we try to ignore the up and down cycles of deflation, that first 2/3 or 3/4 of the graph, left to right, is certainly at a background level. The baseline tilt is going up, right, inflating from somewhere in a range of -6 to somewhere in a range of, we'll call it +6, somewhere like 12 microradians. So significant, not very fast, not alarming, nothing like that, but showing input of magma into the system. And most interesting is that within the last week and a half, 2 weeks there, right, since about the 16th, that the peaks around the deflation inflations seem to have flattened out. So it seems like something has changed in a sense where we're not showing that same tilt, inflationary tilt there, the baseline background. It's holding steady, maybe slightly decreasing. It's harder to tell when there are so many deflation-inflation events close together because they'll obscure that signal. So we'll wait and see what will come out of this one, if we'll peak higher. And of course, the peaks are not super reliable, so time's got to pass, but it appears like it might have actually flatlined there as far as the tilt goes. And now it's still just doing deflation-inflation. Possibly even slightly deflating in the back and the baseline, hard to tell there. If we scroll down to the GPS at the summit there, and maybe you can start working and zooming into that right edge of it, Dane, for the 1 year plot, the past year, because that's the interesting change there, is that there has been a little bit more variation in that cross caldera GPS signal at the summit there, and on that very right end, you see that the after all of our buildup last week, where we were saying that it's getting steeper and steeper and steeper, and that was kind of corresponding to that same inflationary tilt era. And then it seemed like it contracted, apparently, based on this plot, dropped down pretty quick, but it's come back up. It's come back up to about where it was before. So in fact, it seems to be mirroring that same pattern of deflation-inflation as we just saw in a tilt for the last month. And it's been a while since it did it to this magnitude, but if you are able to look in that range of mid-January to mid-February in there, and on that same plot, you do see a lot of up and down wiggles as well in that cross caldera distance. And so it seems like that is what it's expressing again. And we might wonder why it didn't express it as largely in between, in the areas in between. You know, for example, the big deflation-inflation events that happened last month and a couple weeks ago. But without being able to answer that, we can say that there does appear to be that same pattern of change, right? So most interesting is not the up and down, but rather the flattening of it rather than the steep rising again. And so that's fascinating. What would that mean? That means that the pressure is not building as fast anymore, right? It's still high, but it's not gaining as much as it was in that summit area. So that could be because there's a little interruption in the magma supply. Maybe it slows down a little bit, and how long that lasts, who knows? You'd think that given a long-term trends, it won't be long before it resumes some other pattern. But for now, it seems like it's adjusted a little bit, and we'll await and see this slow, small signal change. That's very interesting, the change in it, but not quite clear what that means yet. So that's our GPS. That's the summit one. If you look at a past 5-year one, it's I'll go back into the last one. Yeah, so like that middle graph there, you can see that the biggest drop in the middle of the plot, that's the 2018 eruption, summit caldera collapse, and then over on the right by that January 2021 marker, that little drop, that's the 2020 eruption right in there. And what we just saw in this past couple of weeks doesn't even register on there. So just some context of the grand scheme of things, because the 2018 caldera collapse is still one of the most important recent events that's influencing everything that's happening now as the volcano repressurizes. So down at the bottom, it's just worth mentioning that at Pu'u, we are seeing essentially possibly a very slow spreading, right? That could be the soft flank movement that we've been documenting over the past couple weeks here. It could be magma coming into the rift at some slow speed. It's not going in very fast, but we do believe it is going into that area and not past there. Just want to point out there's nothing dramatic happening elsewhere, because sometimes you can see signals at the summit changing and then signals at the rift changing in the opposite sense, where magma is leaving one area and going to another area. And that's what you'd like to track. And so that's why we're checking the back end of it, so to speak, to make sure that that's not happening. And it's not at the moment.
One thing about Pu'u there, that GPS is the scale, the 0.005 increments. It's really tiny movement there.
Yeah, it is small. Yeah, absolutely. Yeah, good point. Yeah, so that's the GPS there, and we can move on to the stations, and if you go to the USGS monitoring page and map, you can get all the stations that are around the summit, and you can click on them and get these plots. But to expedite things here, I'll just put them all on one page for you guys. And the point of this is that that signal is really localized at Kīlauea Summit. So these first top 4 graphs are all Kīlauea Summit, and it's hard to see the little wiggles, but that's where the signal is showing is only these summit stations. If you scroll down to look at the rift areas, you can see that that's the same pattern as we've seen recently, where it seems like magma is getting past that area of Manaulu, Kananui Ohamo, and further down Kamoamoa and Pu'u areas showing some spreading there, right? And then if you scroll down a little bit more, the whole reason we check this plot there is to look at the Jonica station, which is not showing very fast movement at all. It seems to be fairly flatlined. It could be a slowly wavering background signal there, but it doesn't seem like it's anything major that we need to worry about as far as people living in areas threatened by eruption, right? That day we know will come again someday, but hopefully it's a long time from now. And regardless, we'll keep an eye on things and keep you guys updated as much as we can. So we'll stop there with that GPS and move on to the earthquake rates. And so looking at the earthquake rates for the past year, you can see that there's a clear split. The left side of the graph is a lot more blue than the right side of the graph, and that's because of both the long-term background rates, somewhere around 400 earthquakes per week is a scale there, and spiking up to in the range of 900 earthquakes per week during the seismic crises. One that was in October 2020, that was an adjustment between Mauna Loa and Kīlauea. That pops up as that spike there. And then the spike that happens before January in December, right? There's a 3-bar spike. The left one is an intrusion, and the right 2 are the build up to the eruption between the intrusion and eruption in 2020, into 2020. And really, for most of the year, right, until May, you see that we're down around 200 earthquakes per week as a background level, a lower level during eruption, as there was less pressure building, as there was an open valve for the magma to relieve that pressure, right? Possibly not fast enough, considering what's happening now, but it was able to do that. It was still able to vent, essentially, at that point. The last month, that right end of the graph, in comparison, has a lot more ink. Our average is perhaps back around that 400 earthquakes per week again. So we may be back to that kind of background level and still awaiting a spike of events that may come. So to look in more detail, we'll zoom in on that right little bit. And we'll get to that after looking at the maps first, right? So first we'll look at the map of the past month of earthquakes on Kīlauea. And you can see the general pattern there. It's a big cloud around the whole summit region and that whole upper east rift connector, and a little bit on the upper east rift, not nearly as dense, and then denser on the south flank south of there, right? So that's the whole past month. You can see, that's essentially since it's been 1 month and 1 day since lava was last spotted at the surface of Kīlauea. And so that's essentially capturing that whole post-eruption month there, that first month of post-eruption. And if we advance it to the next map, which is just the last week, you can see a big difference. We might have to flip back and forth in, but go try that the next week. And then what you'll see is that the earthquakes remain dense around the summit, but there's a lot less in that upper east rift area and less on the south flank as well. So there still are some upper east rift area and on the south flank, but a lot less than there were before. And in fact, the map we posted in our weekly update, text update, a couple of days ago, even then was showing much more of that upper east rift connector action. So really, it's a slight geographical shift. It's just retreating from the upper east rift region as far as seismic events, and they're continuing, and if anything, possibly intensifying. Whereas that same volume of earthquakes is happening all in one place, and it's all around the summit, more so than the upper east rift, which is interesting. It's always been a good possibility that magma would reemerge out of the caldera area since 2018 collapse. Introduced so many weaknesses, right? There's so many weaknesses in the rock underground there. There are possible magma pathways coming up. So big change there in the last week. And if we look at the next slide, is going to be the if we scroll down to the earthquake rates and depths there. This is the past week page. And so you can see they include on that weekly page lots of different signals, but go down past the map, and then below the map there's a bar chart, and just below the bar chart there's a cross section, right? So yeah, there it is. And so that's just the past month. And you can see there on the right, there's essentially two blue spikes there of earthquakes coming up. And so that's the last week, essentially. You know, you can see that we've had a couple little flurries, we'll call them, little groupings of earthquakes there. And the reason I want to show this together with that cross section just below it is because we talked about the one that happened last week, just before our broadcast, in fact. It was that deep 4.5 earthquake in the Pahala region, right? And so if you look below that bar that's right around the 18th of June there, right below that in that cross-section area, you can see that line of blue is the earthquakes happening down in Pahala depth. So that cross-section plot below there, it's got depth on the left axis and the y-axis. So that blue stripe comes in at around 30 kilometers, 20 miles down. And the bottom axis, the x-axis, is time. So we're actually the same time increments in the bar chart above as an increment below. So it's just giving you like a slice through, not where left and right, but where up and down within the crust of the Earth those are actually happening. So you can see that 618 period has a big cluster of blue there at that 30-kilometer depth, and that's that 4.5 and all those aftershocks, right? I believe it was over 40 aftershocks greater than magnitude 1.7. And lots more. This plot is capturing much smaller events than that as well, which is why I'm a fan of these plots in particular. We actually get more data out of these plots than we do on a lot of the other interfaces that are available from USGS. So that's it there. But if you look at that rightmost bar there, you do see some blue down at the bottom, but not nearly as much. Right above that blue is a big cluster of earthquakes and more at the surface within the volcanic complex. So harder to see there. So if you go to the next image, Dane, and scroll down to that same rates and depth, that's just the last week. And kind of blown up there, you can see in that cross section, this is essentially both peaks just kind of spread out. So that bump on the left is the Pahala deep quake and its associated events. Then there's kind of a gap there, the 20th and 21st. That's pretty good representation of our current background level, right? So maybe 50 earthquakes per day, somewhere in the range of that, 50 to 60 earthquakes per day. They are happening both within that upper crust and down in the Pahala region. But once in a while, you have a increased activity in both areas, right? So at the left end of the plot there in that cross section, much more blue on the left, and then much more red and orange in the top right of that cross section plot there, with a little bit of blue too there. So interesting pattern there in earthquakes. And so to try to illustrate that, we'll try to load up the IRIS earthquake browser here. And we have here the last week of earthquakes. And we have all of the earthquakes, including the Deep Pahala earthquakes. You see them animating there at the bottom left area, and you see some activity at the summit and upper east rift of Kīlauea, but much more activity at the Pahala region until the very, very end, where you might see a little more activity on the Kīlauea side. Dane, do you have that? Yeah, so I see it now. So on the right side of that animation plot there, that blue line, that's a similar kind of bar graph, right, of the earthquake counts. And so that's showing us the same pattern as we just saw, with two spikes there, one on the left and one on the right, and a couple other little skinnier spikes in the middle that are also Deep Pahala earthquakes. So if we go to the next iteration of the IRIS earthquake browser, we've filtered out those deep earthquakes. Right, so we can look at that bar graph to start, and that's telling you which ones are essentially in that Kīlauea region. So you see we filtered out that left bar and most of those spikes in between. But as far as what's happening on Kīlauea's subsurface, here comes a spike right now under the summit. I know those dots are kind of hard to see, but you see a whole bunch of them appear all at one time there in that summit region, right in there towards the end of the animation. So it's possible to grab that slider under the blue bar, Dane, and drag it back and forth if you like. And
the one note is I don't think the viewers can see the blue bar. I kind of have it cropped out, I believe.
Oh, okay.
But yeah, there was two spikes that corresponded to the previous plots that we were looking at, and in this rendition, we have one spike. Yeah,
so that's something if you like to try out an IRIS earthquake just the last week, and the Pahala earthquakes are all deeper than 20 kilometers, so you can just filter those ones out essentially, and then you can see the kind of earthquake counts. It's a cool way to get earthquake counts for particular regions. So you can define your bounds and your depths and everything, time interval, and you can generate these count plots essentially all the time. So anyways, that just basically tells us that while we do have 2 spikes in earthquakes, it's not all at the surface. We do have some surface activity very recently in the last few days here. Nothing alarming, but it does seem like that corresponds to that shift a little bit to the summit. And it's interesting now that we're kind of to try to tie up Kīlauea here a little bit. We do see that big deflation-inflation event happening. So maybe as a result of whether it's the deflation-inflation, whether it's the flattening, that we're not seeing that expression in an Upper East Rift connector, Upper East Rift as much anymore, and rather we're seeing it more on a summit. So we'll have to wait and see, of course, what it all means, whether those earthquakes are more of the continued adjustment of the changing pressures, or whether it's all increasing pressure underneath there that might come in at some point. So that's the current activity of Kīlauea. But of course, there was more to all the stories, and I was really appreciative of this week's Volcano Watch, which just came out today and will be available on hawaiitracker.com for you guys who want to read it in full here. But I thought that HVO Jefferson Chang did a great job with this week's write-up here. And so the image here is showing 4 stations around the summit, and it's showing 2 different events that occurred very close in time together. So the one on the left is a typical earthquake, right? Which is a result of rock failing and breaking, and that releases energy all throughout, right? From actual snapping of some molecular bond down in there. So a whole bunch of them, right? That second one on the right, that's that magmatic seismic source, as they have labeled, and that's the vibration of the magma moving through some conduit underground. And so nothing's actually breaking. It's like a harmonic vibration, right? I've used an analogy in the past of a recorder, like a little flute, right? So I don't know, a lot of guys of my generation had to have a recorder class when we were very young kids, and it's basically like a flute, right? So you're blowing some fluid, in this case air, through some small conduit, and you can adjust how many vents or valves there are, right, and make different harmonic pitches. But essentially, without doing any of that, changing the notes, just blowing through the thing is putting air through an area to create that vibration. And of course, I'm ignoring all the reeded instruments and kind of reed or anything like that. I'm talking about just more of the maybe blowing through a beer bottle, or blowing something like that might be more analogous. But hopefully, you guys get what I'm trying to get at, is that you can actually have fluid going through a small area, wind whistling through a small alley or what have you, and actually create a vibration that's measurable by those instruments in the ground. And so this is certainly worth a read. I'm not going to read the whole thing to you guys. There are a couple points that I want to pick out. And one analogy that Jefferson makes here is that observations are based on the 5 senses: sight, smell, touch, taste, and sound. And there are analogs in HVO's instrumentation to all of those. So for eyes, it's the cameras and the ground tilt that are measuring what we see changing of the surface. For smell, instead of nose, it's the gas sensors. For touch, it's the thermal cameras and temperature probes. They actually can measure try to interact with the surface of the thing, right? For taste, they're saying it's essentially taste is basically a chemistry experiment with a tongue. It's something no one should ever try with lava. And sampling rocks and lava is analogous to tasting them.
Don't tell me how to
understand
live my
what
life.
the chemistry is.
If I want to lick a rock, I'll lick a rock.
Yeah, well, yeah. It's up to you whether you lick it while it's still 1300 Celsius or 1200 Celsius or not, right? Depends how and why you'd like to go viral, right?
Yeah, definitely.
Okay.
Somebody was saying in chat real quick that she teaches flute recorder class, and she's like, now I know that volcanoes are just big flutes.
Yep, and yeah, when we're I'm talking about the seismic sensor, but we actually also have acoustic sensors that listen to these things, and so yeah, it's amazing, all the different sounds that are put out in all the different parts of the spectrum, right? Sometimes out of the audible range. Oh, yeah, awesome, thanks for that. And so the last sense there, instead of sound, instead of ears, we're listening with seismometers, and I just of course mentioned the acoustic monitors as well. So, and that's of course where Jefferson Chang, author of this week's Volcano Watch, is coming from, is the seismic side of things. And so what he is ending there with is that there are the automatic signals, the rock breaking signals, the ones you see on the left at the top of that graphic there. That's what you see on those earthquake maps. The one on the right, rarely will that ever get picked up by an automatic sensor. It's I'll go back, Dane. Rarely will you get those magnetic signals on the automatic USGS earthquake map. That's something that the analysts and seismologists at USGS-HVO are going through and actually picking out each one of those individually. So that's the work that he's pointing out is happening in the background. And until they tell us what's going on with that, then we'll have to just await their expertise on it. Sometimes they will put in those long period earthquakes into the catalog manually, but not all the time, right? So let's go forward now, Dane, and show you guys some seismographs of the summit region. And so this is essentially picking up it's picking up all the movement on the ground. It's all in blue ink here, of course. So if you go to the HVO monitoring page, you can go into the summit area and look at all the little triangle signals for the instrumentations that are seismometers. If you click on each one, you'll get each of these signals here. So we got to pick one, Dane. Let's see, which one should we pick? Maybe let's pick, I don't know. Well, first let's look at the pattern there.
Which one?
Just
all of them.
First I'm gonna look at the pattern on all of them. So these seismographs that are being displayed now are 48-hour seismographs. That's 2 days worth. And so the one thing that the first pattern you see is a lot darker ink in stripes across the middle and a top and a bottom, right? And that's true in a lot of them. If you scroll down past the East Rift banner and you go all the way down to a Pihikau station right there, I like to show that one because that we know is next to a quarry. So that's a pretty good indication of what human activity looks like, is those two bands right in there, right in the middle of the day there and there. Right? So when we see that heavier ink in those two regions on every one of those plots, then we can suspect that there might be some human influence in those areas of the plot. And our cleanest signals, where the most background quiet exists, is during the nighttime hours in between there, right? So knowing that, we can kind of scroll back up to that summit region, and you see, all the stations have a little bit of ink in the middle here, and we get to the summit, and we do know that there is road construction happening in the national park, and we know that there's visitors driving their cars on the roads nearby. We know there's people walking around. So some of these stations also show that same kind of pattern of more events in the middle of the day than at night, and not to mention the aircraft that are also now flying tourists around, right? So. Okay, so let's pick one of those, and I think the previous the Volcano Watch actually picked out 4 stations. So it picked out maybe let's pick OBL, right? Maybe you can find OBL on there and open up OBL.
There you go.
And so which that all the triangular looking things pointing right, those are all the earthquake signals there, right? So all that's real. And it's interesting that it does appear like there, you actually have smaller events happening more so during the daytime. So that might be part of that construction regime. It's hard to tell, right? But it does seem like there's something happening where there's more activity in the daytime. And then there's also darker ink in the background. So if we look at the quiet periods, and maybe you can go towards the top of that plot there and let's look around, I don't know, like 3 a.m.-ish in there. There's like some really small wiggles in there. That I don't know if you're able to use your cursor to highlight them, but they're really small, darker ink things that are like by themselves apart from any of these bigger triangular signals. That's the kind of vibration signal that these guys are picking out, right? And so when we're looking at this kind of plot off of those maps, we're restricted in our how much time is shown on each line, and also the resolution of it, right? So when they look into the catalog internally at HVO. If you can go back to that Volcano Watch graphic, Dane, that bottom axis there is going from 10:06 to 10:08. That's a minute and a half of time that they've blown up there. So all this will be super compressed, and all this will be super squished down. So they're really able to look in much more detail than is available for you and I online with these automatic plots, right? So under that OBL, yeah, you can find a 6-hour version or a 12-hour version. The 12-hour version doesn't do us a whole lot of good because it's going to show us all the daytime hours. So really, the 24-hour version, maybe we can go or we can look at the 6-hour version first thing at the crack of dawn in the morning and get more signals there. So all that to say is that we'll have to await, because if we go to the next slide there, this reminds us of the Volcano Watch back in April this year, and HVO shared with us these spectral signals, right? So this is how they actually see the data. And all what you're seeing here is spread across this y-axis would all be squished down to a line, and each one of those is the sum wiggle of the instrument. So this was an example of helicopter paths at the higher frequencies at the top, combined with eruptive tremor there at the bottom at the lower frequencies, right? So this is the kind of signal that you're really going to need to see to make a better interpretation of what's happening in those daytime hours, as far as how much tremor there is and how much it's changing, what the long period events are doing. And so we will just have to await Jefferson, his team, all the seismologists there at USGS-HVO to report to us when they have more to tell us about that, about the pattern of long period events and the background seismicity there. So we're only looking at the brittle rock side, and I just wanted to point out that today that that is something that was brought up, and it's definitely worth mentioning. So we'll wrap it up here on Kīlauea with a couple final things. One is just a little bit of a discussion of this pauser or repose, right? Might be a way that's being put. This is a plot from Heliker and Maddox 2003 paper, summary paper of the Pu'u eruption era. And this is just showing in that bottom panel there how many pauses there were per year during that Pu'u eruption. So you can see that in 1992, there were almost 20 pauses. And other years there weren't any, but you see that, all in all, there are quite a lot of pauses across the time of the Pu'u eruption. The next slide will show us a little bit more information about how long they lasted. And you can see that none of them really lasted that much longer than a month during that Pu'u eruption. Of course, we reviewed this in the last Volcano Watch as well. But just wanted to recap there, just say that we're 1/3 of the way now through this 3-month buffer period that is the currently accepted standard by the USGS based on Smithsonian Institute's cataloging there. And so we'll wait and see whether any of this activity in Kīlauea leads to what will be a rejuvenation and a new episode of the same eruption, if it happens within the next 2 months now, or if it takes longer than that, then we can have the right to call it a new eruption by current standards. All right, so a little bit just technical there, but that's arbitrary perhaps as well. But that's how it's one thing we're tracking as a point of curiosity. And last thing before we take our break and say our first thank yous and take Kīlauea questions, is just to point out that there was a research article, Dane posted this on hawaiitracker.com, about this mapping the exposure pollution with low-cost sensor network during 2018. And there was some affiliation with Kohala Institute as well, and it essentially is detailing the change in chemistry from more SO2-rich plumes to more particulate-rich plumes farther away from the source. So more SO2 close to the source, and it reacts with the atmosphere in the presence of water vapor, and especially with sunlight as well, as a catalyst to push that reaction along. And usually that means that the Kona areas get more particulate matter, and areas closer to the volcano, the eruptive sources have more of the SO2. So none of that is new. It's interesting to see that they did that with the low-cost sensors. I want to say that their setup was $1,000 per station, something like that.
Pretty cheap.
Yeah.
Standalone
But
with solar power.
we have heard,
Go ahead.
right? Yeah, which is all great, and it's all a step in the right direction. I've seen a little bit in the comments from some of the people who went through the eruption, that even though this was deployed, the information never trickled to the people themselves for one reason or another. So whether it's given to the authorities or whatever else, that's one part we can still work on to improve in the future, since we're never perfect, and we're always working towards preparedness as well here in Hawaii Island, right?
The
So,
SO2 and the fallout from it is one of the parts of the eruption in 2018 that I thought came along the furthest. That our understanding of exactly from things like the heavy metal fallout around the emission source to the distribution of fallout further down the rift to now this type of research with these low cost. I think they use 32 sensors to try and make a mesh and help
mhm.
give the predictions for certain areas. It's a step in the right direction, but I felt like the knowledge really wasn't there, or a lot of the knowledge might have been there, but the implementation of it definitely wasn't there in 2018. But next time, maybe it will be using research like this. One of the funnier ones or interesting parts to me was that they lost two sensors to the lava. So we didn't just lose GPS to the lava or GPS to Pu'u. We lost some seismometers to the lava as well. But yeah, it's definitely interesting.
Yeah, yeah, gas sensors, yeah, and then they also mentioned humidity taking out quite a few of them too,
Right.
right? That's interesting.
All right. Well,
So yeah,
let's
that's Kilauea.
do some sponsors and get into some questions. We do got to thank everybody that helps make this show possible. We appreciate all the people that tuned in today. Your viewership really does help get this type of information out there. We rely on viewers like you to share this information, like, subscribe, all those types of things. It helps us expand the channel and keep going. But we also want to thank our sponsors that directly support us. One of which is Kalani Tours in Kona side. They do coffee tours, waterfall tours, and volcano tours. Not much to see in terms of glow at the volcano right now, but you can go and learn a bunch of history and a bunch of the cultural references that are up there, or go and view some of the waterfalls. We have some of the best, in the islands. We have some of the best in the world out here. It's incredible stuff. But they take a more small approach to education and the tours instead of the big box style cram everybody onto a tour bus. They do the small kind tours, so really personalized. So if you like take a tour, check them out. Second one is Galeos Bar Grill in the heart of Pahoa, the really mom and pop style restaurant, indoor outdoor dining, some local twists on some traditional dishes, as well as some really good local kind dishes as well. The burgers are great. I really like their fish and chips there. It's some of the best that I found. So if you're in Pahoa, you like help support us, go in Kaleos and tell them that Hawaii Tracker sent you. We also are supported by a grant from the Hawaii Community Foundation, the Puna Strong grant, and that helps us continue this type of broadcast as well. So we thank all of those people that have helped support us, as well as anybody that has made donations. We take donations on hawaiitracker.com/support. So thanks to everybody, and let's get into some questions, huh?
Yeah, let's do it.
All right. So Richard's asked, are Kīlauea and Maunaloa both vents of the magma chamber underneath the southwest rift zone, or like the I believe he's talking about the Pahala?
It's there. So I mean, there is a connection. There is a deep source, which we term the thermal chemical mantle plume officially geologically, right? That's what everyone calls the hotspot, right? The hotspot that's the heat source for all the volcanoes. Now, the hotspots coming through the mantle of the Earth, and above the mantle of the Earth, that lithosphere, that solid part, that's the tectonic plate that's moving across of it, that has different pathways through that crust that each feeds a separate volcano. So there's the same deep source in the mush, and it comes through different pathways through the solid. And then all the solid parts are all leaning on each other. So as one shifts in the other, then they can kind of put pressure and impact the pathways one way or the other. That's the shorter answer. We do have extensive video highlights of that entire process, yeah, on our our science playlist on our YouTube channel there. If you want to go back and look at some of those hotspot videos, probably the questions answers are in there. That's the overview, high level overview I can give to you guys right now.
All right. Boomer asks, what are the odds historically at Kīlauea for the eruption to start again before the 3-month pause period ends?
If it's going to restart, they say that it usually does it in that time, but it doesn't always. I don't know if I have full on statistics.
Right.
What were you going to say, Dane?
Vegas is going to lay you odds that it will start within that 3-month window. They'll give it's not going to be a 1-to-1 bet on that one, because it's more likely that it will restart than not historically. But you can always get outside of that window too. There's no guarantees there.
Yeah, and there's that whole, a little bit of that arbitrariness of whether eruption resumes or whatever, right? So I mean, if it comes back within, let's say, another month, but it comes back in a place a mile away of where it was, do you still call it the same eruption? What if it's a half mile away? What if it's a quarter mile away?
Yeah.
What if it's 100 yards away? So I mean, it's a little bit arbitrary whether you call it an eruption or not, and so at some point it doesn't really matter. Ultimately, the lava is going to come out. If we change the bucket size, then geologically the thing's active and about to erupt, and it's just a matter of parsing our human time scale against that. That's the challenge of it, of course.
We had similar type thing in the beginning of the 2018 eruption, where is this a separate standalone eruption in 2018, or is it part of the continued eruption at Pu'u, the final throw of Pu'u? And that's a discussion that's been had, and people fall on both sides of that one.
Yeah, you could consider it either way, yeah. And of course, for people who actually live down in Lower Puna, Pu'u was a world away from what happened in 2018, so it's a whole different eruption, right? One perspective, right? Although the pathway that sent magma there is the same one. It just opened its final segment there in 2018 after going most of the rest of the way in the previous 35 years. Yeah, interesting stuff there. It's just all just definitions, and we do expect that volcano is going to be active again sooner than later, whether it's within the time frame of terminology or not. That's interesting, and we'll make a note of what it turns out to be, but it's not super important.
Nicholas asks, is the Kīlauea magma chamber recharging?
Yes, we see that with earthquakes. We see that with the GPS overall, the long-term pattern. The tilt recently was showing it as well, and maybe not as much in the last couple of days to the shallow signals, but we think that the long-term rate is fairly. I mean, we have no way of knowing, right? But we calculate things as if the long-term rate was constant. So it'd be surprising for it to stop entirely and start entirely, although we see signals in Maunaloa over the last 20 years that maybe suggest that kind of thing. So we really don't know there. It does seem like the pattern is of long-term of magma coming in, and that's what we see, and that's why we expect it to be on the shorter side of 3 months. Yeah.
We'll do one last question for this round, then we'll do some Maunaloa questions at the end of the next segment. Ron asks, any idea how thick the crust of the lava lake would be now? Just ballparking.
Oh, good question. So it's only been, we'll call it a month, right? Maybe a month and a half, right? So I would ballpark it 4 or 5 feet, somewhere near.
I was thinking 10, but
something like that.
In there,
it'll get to 10 in the next couple months probably. But it's only been 1 month.
True.
Right, so if we get, we might be halfway to 10 in the first month, and then we get the other half in the next 2 months, because it does happen faster at the beginning, and then it slows down over time.
Right, and also we have to mention
so having 5 feet already.
Also need to mention that the top of the lava lake is not uniform. So it depends where you measure it. It could be 50 feet deep if you go and take a position on one of those lava boulders that was in the lake, or it depends just where you go. In some capacities. Right. But yeah, that's about how deep we would be thinking of it. And we will be taking more questions for Maunaloa and diving into it next.
All right. Thanks, Dane. So we'll do Maunaloa. There's not a huge amount there, but we'll go through the the paces here, and start off with our current views of Mauna Loa. That's the summit at Mokuawe'ewe'o. If you scroll down, you can see that there's really nothing showing in a thermal at a scale of 1 degree Celsius there. And below that, our Mokuawe'ewe'o caldera camera and the MO camera. We can just go as far as there. You see that 1949 cone there on the left and that 1941 in the middle, and just a couple views of Mauna Loa. Nothing's really changed. This is when it didn't show up last week. I want to make sure we show that it's actually up in there right now. So yeah, if you want to scroll through the rest of those in, you can feel free, and then we'll jump to the deformation signals on Mauna Loa here next.
It's a good shot from
there's
Mauna Kea over to Mauna Loa right now with all the cloud cover. Just the camera right above the cloud. It's pretty cool.
Yeah, that's a really cool perspective for sure. Like fairly recent camera we've been highlighting for the last couple of weeks now.
Right.
So yeah, Mauna Loa, nothing's changed visually. If we look at the deformation, is we have our daily cycles there, maybe some other longer term cycles. Nothing really obvious in the tilt. If you scroll down to the GPS, there really hasn't been any change in the GPS either. It's pretty much the same as it's been for the last few months now. So not really worth.
It's really flat in there, and it's also on a really small scale. That's the same scale that we're looking at Pu'u, that 0.005 increments. It's a really small scale there. Yeah, exactly. And similar to Pu'u, that might be, like that creeping of that south flank, possibly. I don't know. It's hard to tell how Mauna Loa is connected, and it's a much bigger, more complex structure there. But yeah, so maybe slightly extending, but pretty flat really there. So it's really even on an up signal, if you scroll down, you really don't see it that much either. So not a lot of change there, not really a whole lot to talk about. If we move on next to the earthquakes for the past week in that summit region, you can really see not a whole lot on there. It only shows 34 events or so, right, in the last week. And so if we'll move to the next image that shows the whole last month, you see a little bit more. And we'll see a little bit of action there in that northwest area of the caldera. You see that summit shallow earthquake south of the summit. And you see a lot more of that kind of peppered small events over to on that bottom right corner. That the upper part of the southeast flank is what you're seeing there, right? So that was more visible in that upper reaches about a month ago. It's not as visible in this last week here. So if we go to the next graph here, which is the earthquake rates over the past year, and earthquakes per week is a scale on the left here, and you can see that we really have dropped off quite a bit since May. It's been pretty low there, but it's worth noting that this earthquake rate graph is counting what appears in that previous map extent we just saw near the summit region only. And that's noteworthy because of what is in the USGS update this week. But first, let's look at the last month and zoom in a little bit here in Mauna Loa, just like we did to Kīlauea, and look at that cross section of rates and depths. And you can see there there's no obvious pattern anywhere. It's essentially that kind of background rate. So just to show you what it looks like when you don't see those alternating patterns and regionally, right? So, and the earthquakes per day scale on the left, the highest one on there is 14. So that's really all low level activity there, really. So moving to the actual USGS text update there that was issued earlier today. Similar to recently, right? Not erupting, no significant change, no increased volcanic hazard. That's the bottom line. In the details, looking at the distribution of earthquakes, they say here during the past week there were 166 small magnitude earthquakes below Mauna Loa, of which 37, so only 37, below the summit and upper elevation flanks. 37 out of 166. The remaining 129, all located under the southeast flank, all less than magnitude 3, and all at depths less than 8 miles below ground level. So 129, right? That's most of those earthquakes are on that southeast flank. Possibly all the way to that edge of Kīlauea, northwest of Kīlauea, close to Kīlauea caldera. But that's really the story there. We're not seeing that in any of these previous graphs we saw. We didn't see it on those automatic maps because it's all under that southeast flank and not counted. But that's where this text update comes in here. That's what's happening in Mauna Loa.
is that southeast flank, and it's hard to see that because like I was saying earlier, I like those automatically generated maps because they get those magnitude 0.0, 0.1. When we come to the earthquake map that we have showing now, the USGS normal one, it's got a 1.7 magnitude threshold. So looking at southeast flank there, you see like there's a couple 1.8s that are by themselves. There's 2 yellow ones right in there. And if you go east of there, you might see there's one more recently that was a 1.9. There's a 2.0 in there and a 1.9 in that kind of connected region, right? So it's likely that's the area connecting that cloud of dots in there, but we can't see them and can't really be sure since it's not automatically plotted there. We only have that text to go on, but that is still a southeast flank of Mauna Loa moving, as has been documented. We've been talking about this, it seems like, every single time. So hopefully that is not news to anyone there. So
before you continue on, we have 2 super chats I want to mention real quick. One from Gary Bryan, our friend, who says, I appreciate all the work you guys do and for these updates. Thanks, Phil and Dane. We also have a $4.99 super chat from Jeffrey that says, you guys rock. Appreciate everybody. Thank you guys, both of you.
Mahalo, guys. All right, so yeah, that's where the earthquakes are, right? And so we'll turn now to a local press article. This is the Honolulu Star Advertiser over on Oahu, so on off island, but still local. A bigger media group here in Hawaii, state of Hawaii. And this article is titled, "A Large Earthquake Could Set Off Mauna Loa Volcano," researchers say. So, yeah, a large earthquake can set off any volcano once it's primed to erupt pretty much anywhere in the world. That's like kind of like saying the sky is blue a little bit there, right? So this article has a lot of accurate information, but the way that it's put together is a little bit misleading, and I'm not going to go through all of it, but there are a few things I wanted to highlight, kind of going down, right? This is based off of research that we've been covering from the University of Miami group that we've discussed. Well, it's been 2 months ago now, almost, right?
Yeah.
As soon as the day it came out, we discussed it. We've discussed it again since then. This is the 3rd time we're going to discuss it now because that's how long it's taking the rest of the media to pick up on this, and they are each putting their own spin and taking it, of course, right? So one of the key things I want to point out here is that they interview both Dr. Amelung, who's the professor leading this research group at the University of Miami, and they also interview Ingrid Johansson, geophysicist at HVO, right? Now, this research that's put out covers the period up until May 2020. May 2020. So over a year ago now is the end of this University of Miami data set, right? That's been published, right? So when they asked this guy, and when they published about this, the movement of the volcano, and they asked him about the rates of infusion, he's quoted to say, if the rate of magma influx continues at the current rate, then an earthquake should be soon. And that is just the overall view, the big bird's eye view of the whole situation, right? That if the magma influx rate continues, right? So now we just showed you guys a GPS plot for the past year, where we showed you several different pulses of extension and contraction. So all of that has happened after what was said in that research article. So we know if the rate of magma flux continued at the current, and it didn't. It slowed down, it sped up, it slowed down, it sped up, it slowed down again, and that's where we are now, is in the down again. And so that's one thing to note there, right? Is that when they try to put one quote from the University of Miami groups against the quote from Ingrid Johansson, who quite reasonably talks about what's happening within the last year, she says, I consider it to be in a period of unrest. In some ways, the current lack of deformation is just as intriguing as a previous activity. So she refers to current lack of deformation. So she's actually talking about what's happening now. It's slowed down. So she is current. And this group research is from up to a year ago, right? So that's the first thing to note there. That's a little bit misleading there, right? So they don't know why magma came in or not. And it was one other thing that I want to point out here. So they say that there is movement of the ground underneath the southeast flank of the volcano. That's how it's always been. And they say that the Kona flank is not moving. And because it's not moving, that's where they say that suggests an earthquake is due on a Kona side. And so I could agree that Kona side area, the fault is stuck, but there's no reason for it to pop off unless the volcano is actually swelling. And if the volcano is actually swelling, what gives first, as we're seeing happening right now, is a southeast flank. So unless the southeast flank can stop moving to act as a backstop to allow it to pressurize, to actually push the west flank, that west flank has no reason to move anytime soon. So anyone who's listening is in Kona, don't be freaked out by this article if you happen to come across it. There's nothing recent that's changed any forecast on a Kona side as far as any earthquake, right? In the long term, yeah, we know that area does set off, and we've said for a long time if there's an earthquake, whether it is in that Kona flank or in the Kīlauea area down towards Pahala or in a Kauiki area towards Volcano, that any of those having a big earthquake might be enough to set off eruption through that whole sequence documented in the past. First a summit eruption, and then some break, and then a summit flank sequence eruption that could follow from months to years to decades later, right? So there's a whole pattern of dominoes that have to fall before we get to that point in time. And so it's true the Kona flank isn't moving, but why would we expect it to actually move now if we see the southeast flank giving, and we see that the rate of magma influx has not continued at the same rate as before? So that's where I want to have to call out the star advertiser here today.
Right. And I gotta say something.
Ingrid Johansson
on this thing too.
Okay,
so
Ingrid Johansson. I was just looking at the last, and there's lots of things we can nitpick this thing over and over and over and over. But the last thing here that I think that she really nails it, and this is quoted in here at the very, very bottom of the article there. She says, so while an earthquake might tip off an eruption, the earthquake itself would likely only occur if Mauna Loa was getting ready to erupt anyway. My expectation is we will see additional signs Mauna Loa is building to an eruption before such an earthquake occurs, because of that whole chicken or egg aspect, right? You're not going to set off an earthquake unless the magma chamber is pressurized. That's what I just finished saying. It's exactly the same thing. So I will stop and give Dane a chance here to say what he wants. But I thought this is a good chance for us to discuss the pattern of activity, right? Since we've gone through it so many times in so many different ways, to see someone else's take on it, and in my view, to get it to not have got it quite right. I'll put it kindly and let Dane go rip into it here now.
Yeah, this is just more hype on Mauna Loa. It's been a self-feeding cycle within the media of just hype, building upon hype, without looking at the data at all. And whenever I see some article on Mauna Loa start off with a sentence like, seems like Mauna Loa is a little overdue, or Mauna Loa is overdue for an eruption, I facepalm pretty hard there. Because especially if it doesn't go into the explanation of what overdue means, and you're talking historical averages, and it's only a snapshot of recent history. If you're not doing that, then it's misleading. And it seems like a lot of this research out of this Florida Institute that's been coming out, while there is some interesting aspects of it, and there's some good research in there, it is fodder for the media to turn into hype. And I'm not sure what they can do to improve that. Maybe it's their media interactions. They try and talk down the media instead of trying to drum up the hype to get their name out there a little more. But it from the research itself to how it gets portrayed and how it gets cast is contrast. There's a decent contrast there. And if I could get a message to these guys, I would say start hedging these articles a little bit, or this research, with press releases and things to just tell the media how they're supposed to interpret it, instead of letting them kind of go on their own and come up with whatever story they kind of want to come up with, seeing what they want to see. It gets clicks, though, and that's what, a lot of the goal is with this type of post. But I'll stop ranting now. I think I got most of what I wanted to say out.
Yeah. Thanks for that. Thanks for your input, Dane. Yeah, that's I don't think we need to keep beating it down. Right. Yeah, just to say that it's hard to find any individual sentence in there that's actually not true. I think everything is on its own. But it's like the order it's put in and the way it's portrayed, right? The fact that they are saying, yeah, so they did put out information on how to prepare go bags. That's true, and it's true that the state did suggest that we need to get going on evacuation plans, right? But those things aren't connected to any change in a volcano, right?
Right.
That's just regular everyday stuff happening. But they're linked. They thought it was worth mentioning it in the article, even though it's got nothing to do with it, right? Apart from preparation for that, right? But they're not pitching as preparation. They're putting it as a reaction to something that's going on that we're all expecting this thing to go anytime. An earthquake could happen any day, is what the headline seems to say there, right?
This is basically, this type
So
of writing has gotten so annoying to me that I started writing my own little set, and we'll be releasing that in the coming days and weeks, probably. Just going through some of the basics about Mauna Loa without the hype, with just looking at what we know and what the most important points are for the people that live on the slopes of it.
right, yeah. So yeah, I mean, yeah, it is it's our goal essentially to help you guys understand this research, and so I think the research, there's a lot of great value to the research. And we also have to do a little bit of damage control when other media tries to get a hold of it. And that's a big reason why we continue to do updates on Mauna Loa when nothing is happening, so that if you really want to know what's going on, that's the truth. It's not, we don't have to make anything up. There's enough interesting stuff happening that we don't know what it means. And it is naturally interesting. And problem for the media is that there's no short-term answers. No short-term answers. This is a long-running series that's going to go on our whole lives, right? And I'm not sure we'll be in the same role the whole time, right? But it's, the story is going to play out as beyond the lives of anyone today alive on the planet. So it is fascinating to see how that plays off. So in any case, interesting to talk about the dynamics there, right? It all comes back down to the cycle of water analog, this cycle of loading that summit area with magma and then pushing the flanks away, which can happen with an earthquake. It can happen through intrusion and eruption, driving the stress changes on the fault before the earthquake occurs, right? So that's the kind of the big pattern we've discussed for months and months and months now. And as I've continually suggested, there's a smaller magnitude version of this cycle that doesn't actually have an eruption, but it's to move the magma in the inside recharges, and the flanks move, and it recharges and pushes upwards to the summit and the flanks. And so right now we're in the flanks moving sequence for the last 2 to 3 weeks there, and previous to that we were in the summit inflating sequence, and previous to that we were in the flank moving sequence. And that seems to be what the pattern of the last year in the GPS actually shows us, is this. It doesn't show us unchanging input rates into the volcano. It shows us a cycle, right? And this is also from that same University of Miami research group, right? So it's you can see why it's hard for the media to synthesize all of this, and that's why there is value in what we do here. Yeah, and so
Definitely.
I'll stop saying more about what we're doing here, and just remind you guys that this is all brought to you guys by Hawaii Tracker, hawaiitracker.com. We're here to improve community resilience and preparedness and discuss these things so that we're a little bit more insulated against the media, right? We can take the value of the research more directly and bypass the hype here and get to what's actually important, what we can actually respond to and plan on, right? And so we're really happy to have reported the state putting plans for evacuation plans forward, and all of that, right? That's what we're going for. Is keep talking about it perpetually, and not just when we need people's attention, but all the time, so that it's understood. We have a better base within our whole community. And if you don't hear it from me, you can hear it from someone else, heard it from someone else who has better information than that in the media and more relevant to emergency planning. So I'll stop the soapbox there. So
Right.
any Mauna Loa questions and any more thank yous?
Yeah, let's go through it. Let's see here. So, our, I don't think we have any questions really. There's a comment about
Well, there's not a whole lot happening in Mauna Loa.
Yeah, there's a comment from Denise about how the Japanese government puts out hazard preparation maps for earthquakes every January, and people always seem to think that someone out there is saying that it's overdue, and we're they're putting it out because there's gonna be an eruption. It's kind of just one of those annual things that ends up happening for preparation. It's crazy that they do it every 5 years. Every year. That's pretty good. I think that's something to strive for. It's kind of like the Volcano Awareness Month, but for earthquakes.
Right. Yeah, exactly. Yeah. So yeah, every year they're putting out more data, right? That's, I think, one of the undersold aspects of the USGS, and something we use a lot. And obviously we would love to see more data. We'd love to see the spectral images. We'd love to see the GPS vectors. We'd love to see the INSAR coming weekly. There's all kinds of things that we'd love to see more data. So that's where we'll keep pushing for in the future. So yeah, if no questions in Mauna Loa, yeah, we will wrap it up here, and we'll come back to you guys next week. And yeah, thank you guys for your support. Thanks for you guys who have donated, and not just the guys on our chats today, but our long-term donors as well. Mahalo all you guys. Mahalo Hawaii Tracker. Anything else, Dane?
I think that sums it up.
All right, you guys. Well, on behalf of Dane DuPont, I'm Philip Ong. Aloha.